Which of the following points would be solutions to the inequality y is greater than 2/3 x plus 2? Do I need to graph it in order to check it out and see which ones are above? Well, in this case, it's going to be above the line, right? That would be the place that would work. But we can also do it just by doing some substitution. So I would put my 1 is going to go in for my x, and my 0 is going to go in for y. So I will have 0 is greater than 2/3 times 1, put my 1 in, plus 2. So that's going to be 2/3 plus 2, so 2 2/3. Is 0 greater than 2 2/3? And the answer is no. So this is not, 1, 0 is not a solution. Is for 8 a solution? So again, put my 8 in for my y. Is it greater than 2/3 of 4 plus 2? And that's going to be 8/3. Oh, this is nasty. 8/3 plus 2. Is 8 greater than that? We might need to change this to 2 2/3 plus 2. And I can see that 8 is greater than 4. So the answer is yes. So we can kind of go down the line and just plug those in and see which ones work. Let's do one more here. So let's do the -8, 0. So remember x, y, 0 goes in for the y. So 0 is greater than 2/3 times -8, and then plus 2. So that's -16/3 plus 2, and 2 is what, 6/3? And so -16 plus 6, that's a -10/3. So is 0 greater than a negative? Well, 0 is always greater than a negative, so the answer is yes. So for example 3, Clark is having a party at this house. His father has allowed him to spend at most $20 on snack food. He'd like to buy chips that cost $4 per bag and pretzels that cost $2 per bag. Define the variables. So he's buying bags of chips, so we let C be equal to the number of chip bags, and we'll let P be equal to the number of pretzel bags. Write an inequality to describe the situation. Well, he can spend anywhere up to $20. So for how much does it cost? So C stands for the number of bags. If they cost $4 per chip bag, then 4C is going to represent how much he's going to pay for chips. And since pretzels cost $2 per bag, 2P is going to describe how much he's going to pay for the pretzels. So this needs to be less than, how about equal to? Can he spend $20? If he can spend at most 20? Yes, he can. So that's going to be less than or equal to 20. So here's our inequality that we would write. It says find the intercepts and plot them on the graph. So we'll let C be equal to 0. And if C is 0, I'm going to cover up my C because that's 0. I have 2P is 20, so I'm going to divide by 2 and get 10 for P. And then if P is equal to 0, I'm going to cover up my P. So I get 4C is 20, so divide by 4, and I get that C is going to be equal to 5. So well, let's see, let's label this. Let's label this C for chips, and we'll label this P for pretzels. So the first one's going to be our C, and the second one's going to be our P. So if C is 0, P is 1, 2, 3, 4, 5, 6, 7, 10. And then we have 1, 2, 3, 4, 5, 0. So we have this. We're going to have a solid line here. So we get this. So looks like that, and it's less than. So we're going to shape under the line. Now, we are going to stop at 0 because we can't buy a negative number. So actually, it will just be in this triangle right here. So those are our solutions. So now on part E, it says give 2 possible combinations of bags of chips and pretzels that Clark can buy. Well, he can buy anything in here. He's going to buy in whole numbers, so this is discrete, right? So even though I've got this all shaded in, it's going to only be the intersecting points. You can't buy a fraction of a bag. So so I could choose anything in here. Say for example here, this would represent 1 bag of chips, and since it's up 1, 2, 3, 4, 5, he can buy 5 pretzels. Now, if you want to get the most, bags, then you're going to have to go probably to the edges here. So here's a good edge. This looks like a good spot right there. It's on the line. That's included. It's fair game. So it looks like it's 3 chips and 1, 2, 3, 4 pretzels. Let's do it again. That was kind of fun. Let's go here. We can get 1. So rather than 1 chip and 5 pretzels, we probably would want to go ahead and get 6, 7, 8 pretzels. Let's change that. We'll give them 8 there. But actually anything in this section here, 1 bag of chips and 1 pretzel would work. All right, which graph below represents the solution set of the linear inequality 3x minus 3y is greater than 9? Well, the first thing I'm going to point out is that it's a greater than, so that means I'm going to have a dashed line. So that's really quick. We can throw this, boom, that's gone. Now we need to decide, do we want the one where we shade above or below? Now, tempting right there, right, because it's greater than. But recall that if when we're solving for y, we have to divide by a negative, it's going to flip around that inequality, so we can't be sure. One thing you can do is to test a point. So let's just say we test this point 0, 0 to see if it works, because either everything is in or everything is out. So let's check 0, 0. So if I put a 0 in here, I'm going to get 0 minus 0, so it's going to be 0 is greater than 9. Is this true or false? Oh, that's not true, so that's false. So that means that this is not in the solution, which is good. So that means that everything should be shaded on this side. So to check it out, you can pick something over there like say 5, 0 and make sure that it works. So x is 5, 15 minus 0 is greater than 9. That works. So this is the answer, C.